Let's continue to follow the journey of our fatty Thanksgiving food. We know that it was emulsified by bile salts in the small intestine and taken up by the intestinal cells. So I've zoomed in on an intestinal cell here and said, hey, what's going on? Once these fats are taken into the intestinal cell, we know that they get reesterified, the triacylglycerols. We know that some of the cholesterols become cholesterol esters. And we know that those are really hydrophobic molecules. Those are not going to be hanging around getting transported freely in the blood. So they have to have a taxi cab, so to speak, to get them around. And really, in all actuality, it's more like a crowded subway that gets them through the blood. And our crowded subway is something called a lipoprotein. So a lipoprotein is the transporter of all of these lipids, whether we're talking the phospholipids, the triacylglycerols, the cholesterol, the cholesterol esters. All of them get packaged into one of these lipoproteins. Now here I've tried to start to draw a lipoprotein called a chylomicron. So the first subway lipoprotein that we need is a chylomicron. And what we can kind of see here, if you bear with my artistic endeavors, is that a chylomicron has this outer monolayer of phospholipids and cholesterol. So here I've tried to show a couple of cholesterol molecules in green. We've got our phospholipids that I've shown in black, and I've kind of tried to show the monolayer, but that this monolayer goes all the way around. This, the chylomicrons almost look like a baseball if you cut it in half, where you see that it is packed chock full of, in this case, we've got our cholesterol esters and triacylglycerols in here, and I could keep drawing how they're packed like just an incredibly crowded subway. Cholesterol esters and triacylglycerols all packed in here. Lots of hydrophobic molecules, literally standing room only. So these are our tags and our cholesterol esters, very hydrophobic. And so then outside, the phospholipids with their polar heads hanging out, facing the aqueous exterior, and we could keep drawing phospholipids continuously here in this monolayer. And if you are feeling up for it, you can continue this drawing and complete the entirety of this chylomicron. Another component, a very important component of lipoproteins, are the protein component. So these are called apolipoproteins. Apolipoproteins are amphipathic. That is, they have a region, and you can see here, this region here is going to be very water hating, right? It's going to be tucked in this area. You can think about some of the amino acids that would find themselves there. And then it's going to have a water loving region out here where it's exposed to the aqueous exterior. So this crowded subway car is what will deliver these very hydrophobic fats through the blood. And we'll see that chylomicrons then will take their fats to the tissues. So the chylomicrons will deliver their fats to muscle tissues. And I bet you can immediately guess that particularly amenable to picking up those fats are the dark tissues. So dark meat, and we're probably thinking a lot about that today on Thanksgiving. The dark meat is going to be richer in fat. Remember that it is the type 1 tissue that is using more aerobic respiration and utilizing more fat as fuel than the light meat that tends to run on on glycogen glucose. So also chylomicrons will deliver their triacylglycerols, cholesterols, and cholesterol esters, but mostly triacylglycerols at this point, to adipocytes. And they'll drop those off for storage, and particularly when we're in that rest and digest, we're just going to like keeping those stored in our adipocytes for a day when we need them. So when the chylomicrons have finished dropping off their triacylglycerols at these target tissues, what is left over of them? So now what is left are called chylomicron remnants. Now these chylomicron remnants they're very, very rich in cholesterol. They then travel to the liver. Now let's take another page here to think about what happens to them once they reach the liver. So we've got our chylomicron remnants, they're headed to the liver. And in the liver, we know, especially when we've eaten that very sweet pumpkin pie, inside of the liver, we're likely to see some excess glucose. And that excess glucose, maybe from our pumpkin pie, is, of course, getting converted into pyruvate and then into acetyl-CoA. But if we're really not needing that energy, that acetyl-CoA is going to accumulate, and that acetyl-CoA is going to get used to synthesize fats. So we'll see that excess fat from dietary glucose is found in the liver. So those chylomicron remnants that have now made their way to the liver, they now will take up that fat, and they become something that is very familiar to many of us. These are called VLDLs. And if you will, VLDLs are the next subway. They're the next lipoprotein. So VLDLs are another lipoprotein. Now, VLDLs, they will take their fat to the peripheral tissues, deliver it, including adipocytes. And once they've dropped off their triacylglycerols, they form something called IDLs. Now, IDLs are the next lipoprotein subway. Intermediate density lipoproteins. So we went from very low density lipoproteins to intermediate density lipoproteins. Now, these IDLs will either do one of two things. They will either pick up more cholesterol and cholesterol esters, or they will, about 50% of them will head back to the liver where they'll be recycled. And we'll see what's going to happen a little bit with them there. But let's just note that the really notorious character gets formed when an IDL picks up more cholesterol and cholesterol esters. This results in the formation of the notorious, the epic, the sort of villain of the story, LDL. So those of you who get your cholesterol regularly taken will know that you look at the level of low density lipoprotein. So this subway for our fat and cholesterol transport is notorious because its composition is rich in cholesterol. So they do have a function, right? LDLs do deliver cholesterol to tissues that need it. But if there's a lot of excess, we know that that can lead to plaque formation, and that's associated with atherosclerosis and cardiovascular disease. So we know that is why these get such a bad rap, their richness in cholesterol. Now, I promised you that we would also find out what happened to the other 50% here of the IDLs, and they do go to the liver. And I just want to take note that the liver is also what synthesizes our superheroes. So for every villain, there is a superhero, and that is HDL, or high density lipoprotein. So here's yet another taxi cab, another lipoprotein, I should say another subway car, but it's the one that should be wearing the superhero cape. I don't know, can I give it a superhero cape? That's a lame attempt, but HDL is considered the hero of the day because it is a cholesterol scavenger. So it goes around and scavenges cholesterol. Some of that cholesterol is used to make bile salts. Some of it is excreted in the feces. But also some of it is actually picked up by IDL. So, hey, notice, so HDL goes out and scavenges cholesterol. And then some of that it has scavenged, it transfers to the IDLs, and that's what makes IDLs LDLs. So there's a tight tie between HDL and LDL. Now, let's take just an overarching look, and I'm just going to make a quick flow chart for us to peek at, where we can look at all of our subway cars, our lipoproteins. And we said we started out with chylomicrons. And then we looked at Vldls, very low density lipoproteins. Then we looked at IDLs, intermediate density lipoproteins. And then at LDLs. And then finally we looked at the superhero HDL. Now, if we look at these in this order, we're seeing them in order of increasing protein composition, so apolipoprotein, decreasing percent of triacylglycerol, fats, and then increasing density. You can see like HDL really like totally ripped, right? It's increased density, it's that superhero, but decreased molecular weight. So HDL is much smaller, right, than chylomicrons. But of course, we look at LDLs in this lineup and we don't see anything particularly negative about them, but it's worth marking them as those that are have the highest percent cholesterol. So I now challenge you to go find out what does good blood work look like in terms of level of HDL and LDL, and maybe even overall triacylglycerol. Okay, on that note, let's go eat Thanksgiving dinner.